Okay, so we are going to look on pressure. Okay, so pressure is the force per unit area. That's the definition. Pressure, it is the force per unit area. Okay, that's fine. So what are we saying? We are saying that if we are going to express it as a formula, we'll say that is F over A, meaning that if we are going to look for units, we would say newtons over square meters, because the force is in newtons and the area is in square meters. So the Newton per square meter, we can write it like this. Newton per square meter is also called a Pascal. So that's the unit of the measurement of what? Of pressure. Then usually for regular objects, we usually say that the pressure on the base, pressure on the base will be equivalent to the force over the base area. So that's what we have. That's for regular object. When I talk about the regular objects, I'm simply talking about, say I've got something like this. Okay, this is the shape that I have here, and of course it will have a base. That's fine. It will have a base. So this base area, this one, is the one that I'm saying that that's the base area. So whatever the force that I will have, it will exert a pressure on the base. So it will be simply force. It will be simply pressure is equals to the force over the base area, which is, in this case, if this was suppose that this was A, this was B, so it will be force over A times B, which we know that for a rectangle we'll have length times, or rather we'll have side times side if it was a square. So that's what I have. So of course the next aspect, I'll go to liquid pressure. So under liquid pressure, what I have is actually the pressure of a liquid has got principles. The principle number one for the pressure of a liquid, it increases with depth. This what it simply means. It means that if I've got I've got this container which has got a liquid inside, of course. So I'm saying that pressure on the bottom, if I was going to be spilling the liquid, then it will come here, then of course come here. All right, so these are different heights. So if the liquid is getting out of the container, it's actually going to be passing through. It's going to be showing that what the pressure is increasing with depth. So that's what we have. Aspect number two, pressure at one depth is equal in all directions. at one depth is equal in all directions. So that's pressure at one depth. Okay, so pressure at one depth will be equal in all directions. And also we say that pressure finds its own level. Pressure finds its own level finds its own level. So in other words, even if you pour a liquid into a container, it's simply going to find its own level and it will level up at last. Then the fourth and the last aspect is that pressure depends on the depth, on the density of the liquid. Pressure depends on the density, which I may call rho. So maybe at this juncture I can introduce to you the formula for liquid pressure. The pressure that we have learned when we started is basic pressure, but for fluid pressure it's given by rho g h, whereby rho is the density of the fluid. Okay, then g is the acceleration of free fall. Or acceleration due to gravity. Okay, then of course the last one is h. H is usually the perpendicular height, which is the height of the fluid.